Okay, so hopefully you had a chance to work through the warm-up on your own. Again, watching me do everything and you not attempting it yourself doesn't really help you learn. So, but anyways, so if you didn't do the warm-up, why don't you take a second now, pause the video, do the warm-up. If you did it, let's continue. I'm going to go over the answers here real quick. I think, so I said here's on their peers. So I think I have a little bit of a typo here in my solution. So on my solution, I think I was going to change it, but I never did. So, well, you should probably just say what individuals does the data describe? So you just want to say the peers of the students in the class. Here are the different variables. Again, I've got, so I have this one a little bit old too. So remember, wherever you see that I have qualitative, it just means categorical. So I just went in order. I'll just go up here and go in order. So grade is quantitative, gender is categorical, color categorical, ice cream categorical, number of syllables quantitative, number of pets quantitative, iPhone categorical, hours studying quantitative, left hand, right hand categorical. So again, basically the ones that are categorical are gender, color, ice cream, iPhone, and left hand. All right, this one right here, grade. Some kids want to say that grade is categorical. I don't really have an answer for that one. I kind of can see the arguments to go either way. I would tell you that I try to avoid ones that can be argued on the test because I don't want to have to debate with you about a test. But I think you could justify grade going either way. So if you had grade as categorical, that's okay. It doesn't really make sense for me to find an average of it. I don't know. What does it mean if you're in if the average grade of the school is 9.6? That probably doesn't make any sense. So yes, I'm not really sure. Maybe it is better categorical, but like I said, I can go either way. Again, to do the description, we're just going straight through. So it's a female senior whose favorite color is blue and likes French vanilla ice cream. She has 2 siblings, 1 pet, and an iPhone. She spends 3 hours studying and is right-handed. So you can see I did this one a little bit different than yesterday. I listed it out in more detail as opposed to just quickly bullet pointing everything. So either way is fine. All right, so to go through our lesson here, so we want to kind of figure out some things here. So what's the difference between a data table, a frequency table, and a relative frequency table? So your data table is just like this. Nothing's condensed. It's just all out there. It's just all your data, all right? Your frequency table looks like this, all right? So the frequency table has everything grouped together, and then it gives you the frequency of those things occurring. So this one's about births. So births are not evenly distributed across the days of the week. Here's the average number of babies born each day of the week in the United States in a recent year. So again, you can see here's the births there. The variable being measured in this frequency distribution is the day of birth. And then down here, you want to fill in the table below with the relative frequency. So the relative frequency is going to take these numbers and present them as a percent. So in order to do that, you're going to need to get the total. So you're going to need the total of that, and then you take each individual frequency. So you take the frequency divided by the total. When's it better to use relative frequency over just the regular frequencies? If you're comparing data sets, especially ones that are different sizes, it'll help you a lot more if you can compare the percentages as opposed to comparing the numbers. So what I want you to do right now is take a second here, add up all these, and then find your relative frequencies down here. You can round them to the 10th. There's not a lot of hard rounding rules and stats. So I'll tell you right now, you can round it to the 10th. All right, so again, pause the video, try it. Make sure you know how to do it. All right, you should have found the total to be this. So again, I'm going to take the 7,000. So I would take the first number, 7,374, and divide it by the 79,421. Again, typically we're going to see these written as percentages. So you just want to move that decimal over. So you're going to have like 9.3%. So if that you can't see that, just multiply it by 100%. So there's, and I'm just rounding to the 10th. So I'm rounding to that first decimal place there. Okay. So that one was 9.3%. Here we have 14.7%. We have 16.6%, 16.4%, 16.4% again, 15.9%, and then we have 10.7%. Okay. If you look at these two right here, I might say to you, so what do you notice here? So you might want to tell me, look, definitely Tuesday, Wednesday, Thursday seem to have the bulk of the births. But not only that, it definitely seems to creep up. Like, so Monday, Sunday, and Saturday, there's just not a lot of babies being born on the weekend. All right, we can make a pie chart with this data. I don't really spend time anymore making pie charts with you. Usually you would use technology to make the pie chart. Oftentimes, if we ever see a pie chart question on the AP test, it's going to be a pie chart and they're going to just have you use it to answer questions. What you're going to notice with the pie chart is all the data has to add up to 100%. Back here on your table, if you calculate all those numbers, maybe sometimes they add up to 99.9%, or maybe sometimes they add up to 100.1%. It's just because of rounding, assuming you didn't do any calculations wrong. So again, in that pie chart, it's only going to work if everything adds up to 100%. Typically you're going to find things labeled. They're either going to be labeled like this or they're going to be different colors there. You're either going to list your frequency or they're going to list the relative frequency, and this one's the relative frequency, all right? Sometimes there's a legend or a key there. Again, what do you notice here? These two pieces don't have a very large piece of the pie, okay? When's it inappropriate to use a pie chart? I can't use a pie chart if they don't all add up to 100%. If they don't add up to 100%, don't be using a pie chart. All right? Sometimes we can make something called a bar graph. This one I'm going to have you do. This one right here, we're going to use the relative frequencies. You could just use the regular frequencies. Either one is acceptable. So if I use the relative frequencies, what I want to say here, so this is my birth days. I'm going to have my relative frequency here, and my highest relative frequency was 16.6%. So I could probably, let's see here, if I go by 2, 4, 6, 8, 10, 12, I'm going to go by twos. So this would be like 2%, 4%, 6%. I'm just only going to mark every other one, 10%, 12, 14, 16%. Okay? So then, I should have marked the 14. I know I did that wrong. All right. When I make those bars there, so I'm going to have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So what I want to do here, you don't want to deceive people with your bars. You want to make sure your bars stay the equal width there. So if I'm going to decide, let's say I decide I want to use 2 sets of squares here, I'm going to use 2 sets of squares for every other one of them. The only thing that's going to be different is the height of the bar is going to be whatever the relative frequency was. So for Sunday, my relative frequency was 9.3. So I only want to go up to 9.3. Monday, I'm at 14.7. So I want to get all the way up to that 14.7. Again, as you can see here, a couple things I'm doing here. So I'm keeping that 2 squares width consistent, so you don't want to distort things. I am changing my height based on whatever that relative frequency is. And if you notice here, I'm leaving a space. In a bar graph, we leave a space. I can come over here and do Tuesday. I'm going to do Wednesday. And I don't really want to like skip too much of a space here because then I'm going to like kind of mess things up. Thursday was only at, you can see I'm going to run out of space a little bit. That's okay. I'm going to just extend my graph. There's my Saturday. Thursday went to 16.4. Oops, I think I did Monday wrong. Oh, I guess I'm all right. This one is wrong. This one should be like up here. And then this one is going to be up here. Sorry about that. I knew one of them was wrong. Hopefully you're paying attention and you are yelling at the video and telling me I was doing it wrong. All right, here's Friday at 15.9, and then Saturday is 10.7%. Okay, again, like I said, you want to leave that spacing in there. You want to make sure that your height of your bar is telling you what the relative frequency is. And again, you also want to make sure that your distance there is consistent. Your width of your bars are consistent. Again, if I look at this right here, there's something I notice still that Saturday and Sunday are lower. So if we were in the classroom, I would say to you, why do you think Saturday and Sunday have lower births? Can I control when my baby is born? Let's pause for a second and think about that. If you're ready for the answer would be scheduled births. So if a doctor is scheduling a birth, so scheduling an induction or scheduling a C-section, they are not going to schedule them on the weekends. So you're going to see more births happening Monday through Friday because of the scheduled births. All right, what's the most important thing to remember when you're making those pie charts and bar graphs? Make sure you label things, all right? So don't forget to label things. All right, the good and bad and the ugly. Okay, so some ways to make misleading graphs. So obviously we can make misleading graphs by distorting the area. Maybe we make the scale too big or too small. Maybe we do three-dimensional for something or not. So here's a DirecTV one. It's a couple things going on here. The heights. I don't even know what the heights mean. They're pretty much meaningless to me. I don't know what the widths mean. The widths are pretty much meaningless to me. The difference between 95 and 81 versus 81 and 56, the difference in the numbers versus the difference in the size doesn't really make sense proportionally. So this whole thing is kind of just out of whack. Here's another one from The Economist. So if you just quickly looked at this and you didn't really pay too much attention to the scale, it says the foreclosure picture. So again, if we just quickly looked at it, we would say that foreclosures are increasing. Perhaps they are, but what is the problem here? Are they increasing at this drastic rate here? So no, if you notice here, each one of these bars only represents 1 year until you get to the last bar, and that last bar represents a chunk of 4 years there. Actually 5 if they're counting 8 and 12. So if you think about that big chunk, there must not be, it's only the latter part of 8, so it's 4 years. So if you look at that chunk there, they're putting too many years together compared to the other years, okay? All right, before I show you this page here's another one that was in a magazine. So this one says more than 98% of all Chevy trucks sold in the last 10 years are still on the road. So if you look at this right here, yes, definitely Chevy is far superior than Ford or Toyota or Nissan, Datsun. I don't even know if they make Datsun anymore. But what's the problem here? All right, so if I look a little bit deeper here, I can see that yes, Chevy is more than Ford, but we're talking about a 1% difference here. That's probably not even significant. All right, so again, misleading. Even though that scale's there, if they would have started at 0, you wouldn't see as such a steep decrease there. Okay. All right, two-way tables and marginal distributions. This is the marginal distributions, actually it's the conditional distributions kids kind of get stuck on. The marginal distributions are pretty straightforward. All right, a two-way table, it's just a table that has 2 categorical variables. So in this one down here, we have the superpower preference and we have gender here. So we have 2 categorical variables. The marginal distribution is just finding the distribution, so finding the relative frequencies of just the margins. So you're only looking at the total, so like 30 over 200 or 115 over 200. I'm really not paying attention to the details inside the table, all right? So this is back at that census at school. So it's a sample of 200 children from the United Kingdom, ages 9 to 17, was selected from the Census at School website. The gender of each student was recorded along with which superpower they would most like to have: invisibility, super strength, telepathy, fly, or ability to freeze time. Here's the results. All right, so the row variable is that superpower preference. The column variable is the gender. If you want to pause and think for a little bit, you can pause and come back. How many people does the table describe? 200. How many they selected invisibility as the superpower they'd most likely have? So that's the 30 right there. So then the distributions of the row or column variable alone are called the marginal distribution. Again, I'm ignoring the stuff in the middle. So it says use the data in the table to calculate the marginal distribution in percents. So essentially you're finding the relative frequency of the superpower preferences. So I'm ignoring that stuff in the middle. I'm just looking at the total of the superpower preferences and I'm going to divide it by the total. So for invisibility, I'm going to do 30 divided by 200. Super strength, I'm going to do 20 divided by 200. Again, if you want to round it to the 10th, that's fine. So if you want to pause for a second and do that on your own, that would be great for your learning. And there's your answers. Okay, now obviously we could go the other direction. So we could do a marginal distribution of the gender. So I could do 115 over 200, 85 over 200, and get the marginal distribution of the gender. Again, all this just tells me is how one variable is distributed. It doesn't really take into consideration that all that stuff in the middle. All right, now I want to pay attention to the stuff in the middle. So when I want to pay attention to that stuff in the middle there, what I need to do here is I need to do something called a conditional distribution. So a conditional distribution is that you're conditioning one of the variables has already occurred. So you're doing everything based on one of the variables. How do you know which variable you're going to condition on? You really need to read the problem carefully, okay? So here's our superpower data. And this one says, find the conditional distributions for gender. Round to the nearest percent. So I want to find the distributions for the gender. So I want to know how the superpower preferences are distributed amongst the gender. So what I'm going to do here is I'm conditioning on gender. So I'm going to look at the females just by themselves. So I'm going deeper into the table now. I'm going to go 17 over 115. I'm going to go 3 over 115. So I'm just looking at the females here. So if I do, I'll show you the math here for these first couple ones. So 17 over 115, 15%. The next one is 3 over 115, so 3%. So go ahead and calculate those. I'm going to just write the percents in for the next one. Make sure you understand, if you want to pause the video right now so you can make sure you understand where I'm getting these from. That would be a good idea. Make sure you can get the same numbers as me. But voila, those are the numbers that you should have. Again, this is really interesting now, right? Because before, when I was looking at this, it looked to me that flying was definitely the most popular and super strength was not very popular. But now if I look at it, the story's a little bit different here. Flying really isn't the most popular amongst anybody. It just happened to have a pretty good representation from both groups, so that's kind of what pushed it ahead. But it looks like the girls would really like to be telepathic and the boys would really like to freeze time. It's just kind of interesting. So you can definitely see a little bit more about what's going on with your data when you break it down a little bit. All right, when we break these things down like this, if you notice what happens here is that these are going to add up to 100%. Again, the only reason why they might not is because of rounding. We could make two separate pie charts of this. The other thing that we can do is we can make something called a segmented bar graph. So a segmented bar graph is like a pie chart, but instead of being a circle, it's just like a stretched out rectangle there. What I'm going to do here is I'm going to have, this is going to be my super power preferences. I have lots of cool colored pens. I'll try to do this in just one color for those of you sitting at home who don't have the cool pens like me. So I'm going to have the percent over here. I'm going to just have each of these be 10%. So this is 10, 20, 30, 40. Here's the 50%. 60, 70, 80, 90, 100%. So we go up to 100%. All right. So then I'm only going to have 2 bars here because I only have this one right here adds up to 100% and this one adds up to 100%. Same thing before with this is a segmented bar graph. So this kind of the same thing that happened before. Whatever the width is that I choose here, I want to choose the same width for both bars. So I went 5 across. You don't have to go 5 across. I just knew I only needed 2 bars here and I had all this space, so I figured I'd spread it out. The other thing is that this bar is going to go all the way up to 100%. Both of them. And what I'm going to do here is I'm going to go from the bottom up just so it looks like the same thing there. So for females, they freeze time is 17%. And again, I'm going to just give this a pattern. For the boys, the freeze time is 38%. 10, 20, 30, so I'm almost up here. So I'm going to make a little key over here. So this is freeze time. All right. After that 17%, 31% of the girls would like to fly. So you could try to figure out what 31% is. Well, the way I kind of do this is I say 31 plus 17. That would be 48. So my next line should be at around 48. And I don't know, maybe this one I'll color in completely. I should probably, it would be nice if I colored the other direction. Maybe I'll just color both directions. All right, and then for the boys, if I do 38 plus 21, I get 59. So then I would be at 59. All right, so again, I'm going to make that key over there. And this is my fly. All right, so we were at 48 here. The other thing you can do, so I'm not sure what pattern I'm going to use here, but this is going to be invisibility. This is going to be super strength. And this is going to be telepathy. You could also start to come down from the bottom if you wanted to. So for the girls, 15%. So there's 10%. So this would be 15. I don't know, maybe I'll give them a little asterisk there. Little stars, I guess that's ended up being more like stars. The boys is also at 15%. Super strength is only 3% onto that 15, so I'm really only at 8. So maybe I'll just leave that one white. And then 20 to 5, 15, so that would put me at 35%. So then I'm done here. I'll just leave that white. And then the last one right there. So then what I have left here, so I need to like mark this one up somehow. So maybe I'll do some polka dots. That was this one right here. There's the telepathy. Okay. All right. What does it mean for 2 variables to have association? So it means that specific values of one variable tend to occur with specific values of another. So in this one, and how can you tell by looking at it? So I can see here that it looks like these variables right here are more likely to occur with the females. This is more likely to occur with the males. So can I conclude that boys and girls differ in their preference of superpowers? So I could say yes here. Girls are more likely to choose telepathy and fly than boys. Boys are more likely to choose freeze time and super strength. Could we see that from the table? Absolutely, but people like to look at pictures versus looking at numbers seem to scare people. So if we put things in pictures, they seem to feel more comfortable with them. All right, one thing to keep in mind here is that there are other, there is another conditional distribution here. We could have done the conditional distribution by of superpower strength. So I could have done it the opposite direction. So I could have found like the 17 over 30 and the 13 over 30 and the 3 over 20 and the 7. So I could have gone that way. And I would have had 5 bars. So I would have had a bar for like invisibility, super strength, telepathy, fly, freeze time. And then I would have, the bars would only had 2 segments. So because it would only been female or male. All right, so just don't forget that there's another way to do it. All right, this example right here, I'd like for you to try on your own. So you can pause the video. When you're ready, you can unpause it and take a look at my solutions. so here's one way to do it. So this is a segmented bar graph, like what we just did. I did this using technology. I got my luxury cars, I got my SUVs, I got nice colors in there, so you can see here again the difference. I can see from this that luxury cars, so I can definitely see that black and silver are probably the most popular colors here. I can see that SUV trucks and vans are more likely to be white than the luxury cars. I can see that the luxury cars are probably more likely to be that white pearl versus just the regular versus white pearl over here. So we can see a couple different things there. Another way we could do this one is you could do this one's called a side-by-side bar graph. So if you notice here with this one, I've got luxury cars and SUVs, trucks. So I've got the height, so this is black, that's the percent for luxury cars, this is the percent for SUVs, trucks. I don't have a space between those bars because they're still within that same color black there, but then I take a space. So remember, in that bar graph, we have a spacing. So I have a space before I start the next color, space before I start the next color. Again, this one's kind of nice because they're right next to each other, so I can definitely see some clear differences here. I can see there's a huge difference in that white pearl. I can see there's a big difference in the white. Even the black is kind of different, okay? Silver is about the same for both. These colors down here are not very common for either one of them, so I can kind of see that. This last graph, although it's not wrong, don't really care for it that much. It's just a little bit harder for us to see. Basically what this one is doing is it's doing a bar graph, but segmenting it, but stacking them. So they're not up to 100%. So it's just kind of weird a little bit. It's just kind of hard to compare. Like I said, it's not really wrong. It's just not ideal. And if you didn't figure it out, those numbers were already in percent, so you didn't need to convert them. They already added up to 100% across. Again, we talked about some things that we saw already. There's many other things that you could possibly say for this. This is just, you know, a few sentences there, okay? All right, so as you saw in that last example, there's many ways that you can display the categorical data. It's really up to you to decide the best representation. Oftentimes you'll be told what kind of graph you're making in this class, but, you know, in the real world, you would just have to pick whatever one you would like to, you know, you think is best. The book does outline a 4-step process here. I'm not going to really enforce it too much at this time. However, just something you want to think about. So you will see the state plan do conclude, and I will enforce it later on. But like I said, at this time, I'm a little bit lenient. But state what's the question that you're trying to answer. So what do you want to know? How are you going to go about answering the question? So what statistical techniques does the problem call for? You want to make graphs? You want to carry out your calculations? You want to give your conclusion, practical conclusion in the setting of the real world problem. All right, so here is the problem set for this note packet.